Welcome to the Deep Dive, where we cut through the noise and get you straight to the most important insights. Today, we're plunging into the fascinating, fast-evolving world of how businesses manage and truly leverage their data in this wild digital landscape.
That's right. Our mission for this deep dive is to really unpack the critical concepts of extract, transform, and load, or ETL, its evolution to ELT, and the whole surrounding ecosystem. We're talking cloud migration, robust data governance, strategic data orchestration.
Right.
We're aiming to give you a shortcut, sort of, to understanding this complex but absolutely essential part of modern business, hopefully revealing some surprising facts and, some truly actionable insights along the way.
Because here's the core problem, isn't it? Data often exists in this fragmented, kind of messy state, scattered across countless sources. You think your Shopify sales, Google Ads performance, Salesforce customer records.
All over the place.
Exactly. All these different platforms, each holding a piece of the puzzle.
Yeah.
And trying to manage that data manually, it's just an incredibly time-consuming and inefficient nightmare, like trying to herd digital cats.
Yeah, that's a good way to put it.
So let's start at the very beginning. When we talk about ETL, what exactly is it, and what makes it such a foundational piece of today's business environment?
Okay, so ETL, which stands for extract, transform, and load, basically automates that messy problem you just described. It involves software that connects to dozens, sometimes hundreds, of data sources.
Wow.
Yeah, it schedules the extraction jobs, runs transformations to clean, filter, and structure that data, and then finally loads it into a central place, like a data warehouse or a data lake.
Okay.
What this does is simplify operations. It moves things from complex coding to what's often a point-and-click interface, or maybe for more technical teams, configuration via YAML. That's a human-friendly way to write configs, or SDKs, software development kits.
Okay, so if that's ETL, which sounds very sequential, right? Extract, then transform, then load. What about this flipped concept I've been hearing about, ELT? Where does the transformation happen then?
Right, ELT is exactly what it sounds like. Extract, load, then transform. The key difference is that with ELT, you extract all the raw data and load it first directly into the data warehouse or data lake.
Ah, okay. Dump it all in first.
Pretty much. And only then is it transformed, often using specialized tools like dbt, that's data build tool, which lets teams transform and model data right inside the warehouse itself. The choice between ETL and ELT, well, it really depends on a company's specific tech stack, their latency needs, how fast they need the data, and frankly, their internal data engineering capacity. Both approaches definitely have their strengths and use cases.
But really, why should you, our listener, care about these technical acronyms? ETL, ELT. What's the real practical impact of these processes on a business's bottom line or its competitive standing?
That's the crucial question. And these processes are critically important for several big reasons. First, there's data freshness. Real-time data isn't just a nice-to-have anymore, it's become essential.
Right.
For use cases like detecting fraud as it happens, or optimizing an advertising campaign on the fly, or getting truly accurate inventory insights. Waiting even 24 hours for data updates, it just doesn't cut it anymore.
Definitely not.
And the core insight here isn't just faster is better. It's that real-time data is basically rocket fuel for competitive advantage. McKinsey actually found that companies leveraging real-time data are 23 times more likely to outperform competitors in customer acquisition and retention.
23 times? Wow, that's not a small number. That's a significant leap.
Right.
So it's not just about small gains, but a truly transformative advantage.
Precisely. Second reason is operational efficiency. Building and maintaining these complex data pipelines manually, it's incredibly labor-intensive.
I can imagine.
ETL and ELT tools significantly reduce this overhead. It means fewer engineers are stuck, babysitting APIs and wrangling data constantly. It frees them up for much higher value work, like building new products or doing more advanced analytics.
Makes sense.
And finally, these tools are powerful for driving revenue. They literally transform raw, disparate data from all those sources into a true revenue-driving asset.
How so?
Well, in retail and e-commerce, for example, unified data pipelines allow for much more accurate customer segmentation. That directly leads to increased conversion rates and higher average order values. Or think about predictive inventory management. That's a direct result of these integrated data flows. It helps businesses avoid costly stockouts and reduce excess inventory. Both hit the bottom line hard.
I can definitely see how that efficiency scales. Now let's shift gears a bit. When we talk about moving to the cloud, there's this concept of data-first thinking. It sounds strategic. What does that actually mean in practice, and why is it so relevant?
Data-first thinking, yeah, it's crucial, and it raises a really important question for any organization planning a cloud move. What's the plan for your data before you even start migrating applications?
Thinking ahead.
Exactly. It's about defining your comprehensive data strategy upfront, right when you're designing the cloud adoption plan.
Yeah.
If you don't have a centralized data design from day one, just lifting and shifting applications can unfortunately lead to siloed, disparate data systems in the cloud.
Creating new problems.
Precisely, which then significantly increases the effort and the cost needed later on to build a central data lake or warehouse. I actually saw a large, fast-moving consumer goods company save a considerable amount of time and money because they adopted a data-on-cloud approach early, specifically using Snowflake for their data warehousing right at the start of their cloud journey. That clarity up front just made all the difference. Avoided a lot of future headaches.
And as you centralize and consolidate all this valuable data, the guardrails, the safety nets become incredibly important. So tell us about the role of data governance here. How does it ensure not just the quality of the data, but also its security and trustworthiness?
Data governance is absolutely pivotal. You can't really have a successful ETL migration or a useful data platform without it. It establishes the policies, the processes, the controls needed to ensure data quality, security, and compliance throughout its entire life cycle.
Okay, so what does that involve?
Well, a few key things. Data lineage and traceability, for one. This gives you a comprehensive view of how data flows from source to destination. It documents all the transformations and traces the origin, so you always know where your data came from and what happened to it.
Like a map for your data.
Kind of, yeah. It also involves continuous monitoring and auditing. That means tracking data movement, transformations, and quality metrics in real time, so you can promptly detect and fix issues as they arise. And finally, it's about risk mitigation, actively preventing things like data corruption or operational disruptions through structured approaches, including robust data quality checks and having contingency plans.
So it's not just about getting the data there, it's making sure it's good data and safe data every single step of the way. I've heard some horror stories about what happens when this gets neglected. Is there a true story, that really highlights the high cost of ignoring data governance?
There is, unfortunately, a very real one. I know of an e-commerce company that was migrating its Elasticsearch database, that's a popular search engine database, to the cloud. During the migration process, somehow a public IP address was inadvertently left open, exposed.
Oh.
Yeah, a well-known Ukrainian hacker group found it, managed to access customer personal details, credit card numbers, the works. It led to a significant ransom payment and, of course, huge reputational damage. And the thing is, this incident could have been completely avoided. If they had enabled proper cloud governance tools, those tools would likely have continuously monitored for security loopholes like open IPs and misconfigurations. In fact, misconfiguration is the leading cloud security threat. It accounts for something like 68% of issues. Proper governance can lead to about 33% fewer security lapses.
That's a stark warning.
It really is. And it highlights this concept of shared responsibility in the cloud. The cloud providers, like AWS or Azure or Google Cloud, they're responsible for the security of the cloud, the physical data centers, the core infrastructure. But the customer, you're solely responsible for security in the cloud. That means your applications, your data, and critically, your configurations.
That hacker story really hammers home how much of this hinges on human awareness and having robust processes in place. Is this where a concept I've heard about, like a Cloud Center of Excellence, comes into play?
Absolutely. The Cloud Center of Excellence, or CCO, is exactly that. It's typically a team or a framework within an organization dedicated to driving structured cloud adoption, effective cost control, which is huge in the cloud robust security, and continuous innovation. It's about creating those internal guardrails and best practices you mentioned.
That makes perfect sense.
Right.
So speaking of structured approaches,
Yeah.
how do companies actually go about migrating their existing ETL systems? These are often deeply embedded legacy systems. Do they usually go for a big bang approach, move everything at once, or is it more gradual?
Well, the Big Bang approach does exist. Sometimes it's driven by really tight deadlines, like needing to exit an old data center contract quickly, so they move everything at once, often with very little modernization during the move itself.
Risky, maybe.
It can be, yeah.
Hmm.
The recommended agile approach, especially for continuous modernization, is actually called incremental rationalization. This is where you migrate in phases, piece by piece, optimizing as you go. It's much more manageable. There's also the 7Rs framework, which helps categorize strategies. You can rehost, which is basically a lift and shift, quick, but maybe not optimized. You can replatform, where you make some minor cloud optimizations without changing the core application code much. Or you can refactor, which is more involved, re-architecting applications for cloud-native benefits, like using microservices.
So different levels of effort and benefit.
Exactly. And we often see the M plus M or migrate plus modernize strategy as being really effective. This integrates modernization directly into the migration scope from the start. The goal here is to prevent your shiny new cloud environment from becoming new legacy just a couple of years down the line because the underlying applications weren't updated.
That's a smart way to think about it. Prevent future tech debt.
Right. And critically, given the complexity and often the fundamental incompatibility between old legacy on-premises systems and modern cloud-native services, a completely manual migration approach for ETL. It's just not feasible at scale. Automation plays a pivotal role here.
How so?
Automation tools significantly reduce the manual effort involved. They help mitigate risks, and they ensure consistency across the migration. Tools like, say, Bitwise's ETL converter can automate large chunks of the code conversion process between different ETL platforms. And validation utilities are absolutely vital to make sure the data that arrives in the cloud actually matches the source data.
Those tools sound pretty essential then. Let's talk about some specific real-world examples. How have companies actually navigated these potentially massive transitions?
Certainly. We have some great case studies on legacy ETL modernization. For instance, one client successfully migrated their legacy SQL Server integration services, SSIS jobs, over to Azure Data Factory. That significantly enhanced their scalability and really cut down on maintenance overhead.
Yep.
Another project involved moving Informatica ETL jobs to AWS Glue. The goal there was optimizing for a serverless architecture, which often leads to better cost efficiency because you only pay for what you use. And a third example involved transitioning data stage jobs to Azure Data Factory, achieving a smooth migration and minimizing costs, largely thanks to automation. The key takeaway from these is that having specialized tools and experience really does drastically cut down the migration time and the associated risks.
So expertise matters.
Immensely. Another compelling example comes from a Durabid case study. It involved a company migrating a decade-old SQL Server data warehouse from their own servers to Azure Synapse Analytics. The results were pretty staggering.
Oh, yeah.
They saw a 65% reduction in report generation time. Think about it, their monthly sales dashboards used to take over 3 hours to run. After the migration, they completed in less than 20 minutes.
That's huge.
Absolutely. They also saw a 40% decrease in infrastructure overhead, gained real-time inventory insights, which they never had before, and significantly enhanced their security posture.
But it wasn't all smooth sailing, I assume.
No, definitely not. There were challenges. They had to manually refactor over 700 stored procedures. That's a lot of custom database code. They faced complexities with getting incremental data loads working efficiently in the new environment. And interestingly, they experienced unexpected cost spikes initially.
Ah, the cloud cost surprise.
Exactly. It was due to some pipeline inefficiencies they hadn't anticipated. This actually led them to implement strong cloud cost governance policies, FinOps, essentially. And this whole experience really highlights why having what we call the 4Ops in place is so important.
The 4Ops.
Yeah. DevOps for collaboration between development and operations, CloudOps for managing the cloud infrastructure itself, FinOps, which is crucial for understanding and optimizing cloud spending, and SecOps for security operations. Having these disciplines, often coordinated by a dedicated Cloud Center of Excellence, CCO, is key for structured adoption, effective cost control, robust security, and continuous innovation in the cloud. FinOps, in particular, becomes invaluable.
That's a powerful transformation story with some very clear lessons learned about planning costs and needing those operational frameworks. So we've talked about the past and present of data integration, but what about the cutting edge? What does the current landscape of modern data tools look like? Are there new players beyond the traditional ETL vendors that are reshaping how data is managed?
Oh, absolutely. This is where things get really interesting and dynamic. You see, traditional ETL tools, like maybe an older version of Informatica Power Center, they were largely designed for a world of, let's say, limited scale, limited formats, and limited ambition. They typically handled structured data, often in batches, maybe once a day.
The old way.
right. But today, modern platforms like Databricks, they're built for a completely different reality. They're designed to handle thousands of events per second. They support incredibly diverse data types, structured, semi-structured, even completely unstructured data like text or images. They handle real-time processing natively, and maybe most importantly, they offer seamless integration with AI and machine learning workflows, which is becoming a huge driver. So, much more capable.
Massively so. Databricks, in particular, champions this lakehouse architecture. It's an innovative approach that cleverly combines the raw, flexible storage capabilities of a data lake with the performance, governance, and familiar SQL querying features you'd expect from a data warehouse.
Best of both worlds.
That's the idea. It means you don't necessarily need to duplicate datasets into separate systems, which saves a lot of complexity and cost. Databricks also has built-in support for the entire machine learning lifecycle through something called MLflow, which helps manage and track experiments and models. And it's all scalable and cloud-native. They're growing incredibly fast, serving over 10,000 customers now, with over $3 billion in annual recurring revenue.
Wow, that's serious growth.
It is. And beyond pure analytics platforms like Databricks, you also have innovative tools focusing on real-time bidirectional synchronization. Think of tools like StackSync. Their goal is slightly different. It's about achieving operational data consistency across your core business systems.
Like between my CRM and my ERP. Exactly. CRMs, ERPs, various databases, ensuring they all have the most current, consistent view of customer data, order data, whatever it might be, often with sub-second latency. This transforms data integration from being this painful, periodic liability into more of an automated, real-time utility.
That sounds incredibly useful.
It is. And for teams that prefer more control, more flexibility, maybe want to avoid vendor lock-in, there are also strong open source alternatives now, like Airbyte and Meltano. These offer full control and pipeline as code workflows, which developers often love.
How do they differ?
Well, Meltano functions more like a framework, integrating other best-of-breed open source projects like Airflow for orchestration and dbt for transformation. Airbyte, on the other hand, is focused on building a huge catalog of connectors very rapidly and offers a distinct pricing model, often not based purely on data volume, which can be attractive compared to some commercial tools.
That's a fantastic overview of the new guard and just how much innovation is happening. Now, looking at all these options, the established players, the Databricks Lakehouse, the sync tools, the open source options, a perennial question always comes up for businesses. Buy versus build. What's the latest thinking there, especially when it comes to these complex data pipelines?
The eternal buy versus build. It's a crucial strategic question, no doubt. And while the idea of just writing some Python code might seem like the free option up front.
Famous last words sometimes.
Exactly. It often seriously overlooks maintenance costs, knowledge dependencies, and particularly performance issues when you try to scale it up. Building these solutions from scratch means your team is responsible for every bug fix, every API change from a source system, every scaling challenge, every security patch.
The hidden total cost of ownership.
Precisely. When you actually factor in the salaries of the engineers needed just for the initial development, let's say, conservatively, $45,000 to $52,000 for maybe 3 engineers for just 6 to 7 weeks of work to get a basic core setup running, buying a ready-made supported solution can often be significantly more cost-effective in the long run. It offloads that huge operational burden and lets you leverage the expertise already built into the product.
That's a really important perspective on those hidden costs. So with all these modern tools and data flowing at incredible speeds, this term data orchestration keeps popping up. It sounds like the next big frontier. What exactly is it, and why is it suddenly so critical?
Data orchestration is essentially the automation and the centralized administration of your end-to-end data pipelines. Think of it like the conductor of an orchestra.
Okay.
You might have the best individual musicians, your data ingestion tool, your transformation tool, your data quality tool, but without a conductor coordinating them all, you don't get a cohesive symphony. You just get noise.
Right. Makes sense.
Orchestration ensures all your data processes, from ingestion and cleaning through transformation to delivery for analytics or AML models, all work together seamlessly, efficiently, and reliably. And the fact that some studies show 87% of businesses fail to fully leverage their data, often due to the sheer complexity and siloed nature of their data processes, really underscores how critical effective orchestration is becoming. That's a lot of potential insight, a lot of potential symphonies being lost.
87% is a huge number. That really highlights the need.
It does, and we've seen some compelling examples of orchestration tools making a real difference. For instance, AWS Step Functions, which is Amazon's serverless orchestration service, helped the online retailer Zalora reduce their SAP system refresh time, a complex process, by an impressive 60%. They went from 5 days down to just 2 days, all through serverless automation orchestrated by Step Functions.
Wow, 5 days to 2.
Yeah. Another example, Flight, an open-source workflow automation platform originally from Lyft, empowered Spotify to automate its complex financial analytics and profit and loss projections. This cut down a manual quarterly process that used to take 3 to 4 weeks of intense effort.
That's transformative.
Absolutely. Google Cloud Functions, used for serverless compute, enabled HomeAway, now part of Vrbo, to have its development time and reduce infrastructure costs by over 66% for building a real-time recommendation engine by orchestrating the different pieces. K2 View, a data product platform, allowed AT&T to drastically slash the time it took to provision test data for developers from literally weeks down to mere minutes, which improved their time to market by 80%.
Weeks to minutes, that's incredible.
It really shows the power. And one last example showing how governance fits in. Atlan, which is primarily a data governance and cataloging tool, assisted Tide, a UK digital bank, in automating their GDPR right-to-be-forgotten compliance. This transformed what was a painful 50-day manual process into just mere hours of work by automatically finding, tagging, and helping secure personally identifiable information, PII, across their systems, all orchestrated as part of their data workflows. It's about automating that entire workflow end-to-end, safely and efficiently.
That truly shows the power of these automated orchestrated workflows and the efficiency gains possible. So pulling this all together, what are the key takeaways? The main best practices for you, our listener, as you try to navigate this constantly evolving data landscape?
Okay, to summarize, I think there are several really actionable best practices that can make a profound difference. First, proactive data cleansing. Clean your data before it even enters your ETL or ELT process, if possible. Don't waste valuable processing time and money on bad, unusable data downstream.
Garbage in, garbage out still applies.
Always. Second, incremental updates. Wherever possible, implement incremental data updates. Process only the new or changed data since the last run, rather than reprocessing entire massive data sets every time. It's far more efficient.
Makes sense.
Third, optimize performance. Keep your databases and target tables lean. Use techniques like partitioning and data caching where appropriate. They can provide significant performance boosts. Fourth, measure everything. Establish clear metrics for your data pipelines, things like data freshness, pipeline duration, error rates, and consistently track them. This lets you monitor effectiveness and quickly spot areas needing improvement.
If you can't measure, you can't manage it.
Exactly. Fifth, embrace continuous modernization. Don't just migrate and forget. Actively plan and execute ongoing modernization efforts. Technology in this space moves incredibly fast, and you really want to prevent your cloud environments from becoming new legacy just a few years down the road.
Stay current.
Right. Sixth, and this is crucial, prioritize data governance. Implement robust data governance frameworks from day one. Don't treat it as an afterthought. This is your best defense against those costly security lapses we talked about, and it's your guarantee of data quality and regulatory compliance.
Non-negotiable, really.
Pretty much. And finally, think beyond just the initial price tag. Think about the total cost of usage, or TCU. Consider factors like operational offloading. How much manual work and maintenance are you saving by using a managed service or tool? And potential savings on specialized IT staffing. Cloud solutions, through their compute efficiency and elasticity, scaling up and down automatically, can actually offer significant cost savings, sometimes up to 9 times compared to traditional over-provisioned on-premises setups when you factor in all these elements of TCU.
Up to 9 times. That's a compelling figure when you look at the whole picture. It really can't be overstated then. This has been a truly illuminating deep dive into how critical effective data integration, governance, and now orchestration are for modern businesses to really thrive and innovate.
It truly can't. And perhaps a final thought to leave listeners with. As we consider the increasing integration of AI into virtually every business process, what novel demands will that place on our data pipelines in the very near future? And maybe more importantly, how quickly will this next generation of data tools need to evolve again to meet those new challenges?
A very compelling question to ponder indeed. Thank you for joining us on the deep dive.